Okay, let's look at this question from the grade 12 physical science paper, June 2018. So it says block P of unknown mass, here's block P, is placed on a rough horizontal surface. It is connected to a second block of mass 3 kilograms by a light inextensible string passing over a light frictionless pulley as shown below. Initially, the system of masses is held stationary with the 3 kilogram block a half a meter above the ground. When the system is released, the 3 kilogram moves vertically downwards and strikes the ground after 3 seconds. Okay, so they told us the initial velocity was 0. So it says ignore the effects of air resistance. Define the term acceleration in words. Now this definition is not specifically stated in the grade 12 curriculum, but you should know it from grade 10. Acceleration is the rate of change of velocity, okay, because velocity is in meters per second, and if your velocity is changing, if you're either going faster or slower, you are accelerating, and we measure it per unit time, so it's rate of change of velocity. Now it says calculate the magnitude of the acceleration of the 3 kilogram block using equations of motion. Okay, so here are my equations of motion up in the top corner because we know them from grade 10 and we use them for our projectiles. So what do we have here? Do we know VF? No. So we can't use this formula, we can't use this formula. We can't use this formula because we don't know VF, which leaves us with this one. So for 2.2, we're going to say delta X or delta Y, seeing as it's moving vertically, but I'm just writing delta X. Okay, delta X equals VI delta T plus a half AT squared. So what is my delta X? The block moved a half a meter. Okay, what was my initial velocity? 0. So I'm just going to write my 0 in here. Okay, I really don't like this 5. 0. Okay, plus a half A, and how long did it take? It says 3 seconds. So it's a half of 3 squared. So 0,5, my handwriting is getting worse. 0,5 equals a half of 9, because this is 3 squared. A half equals 4.5 A. So A equals, what is A? A equals 0,11111, but we can just leave it with the 2 ones. Meters per second squared in the direction of motion, or we could say it's downwards. Okay, now it says calculate the tension in the string. Now whenever we want to do a calculation like this, we need to draw a diagram. So we want to calculate the tension in the string. The easiest one to use is this 3 kilo block. Okay, so if we look at the 3 kilo block, if we draw a force diagram, the weight of the block, Fg, is pulling it downwards, and directly opposed to this is T, the tension in the string. So if we say the direction of motion is positive, where are we here? Tension in the string, 2.3. Let's change the pen color. Okay, so for 2.3, okay, we're going to say the direction of motion is positive. So the direction of motion is downwards. So what force is going downwards is Fg. What force is going upwards is T. And this is going to be equal to MA. So you can write this first, but you should ideally also write F net equals MA just above this, okay? But usually if you've written Fg minus T, they'll give you the marks. So what is Fg? Fg is the force due to the mass. So the mass was 3 kilos, so 3 times 9.8 minus T, which we're trying to discover, equals the mass 3 times the acceleration, and we can use the value from the previous question if we kept it in our calculator. So by maths, we're going to end up with something like 29,07 newtons, okay, and that tension will be spread throughout the string. Now it says the magnitude of the kinetic frictional force experienced by block P is 27 newtons. Then it says to you, draw a labeled free body diagram for block P. So here is block P over here. Look, there's 4 marks, so we need 4 forces. We need to, I'm going to draw it over here in this little mingy space here. We need to make sure that we draw a little circle, a little filled in blob for the body, and then every arrow must come out of here. You need to make it with an arrowhead, and you need to label it. So the first force we experience is the force due to the weight, Fg, and then the second force is the normal force. Okay, let's rub out this P over here. We know it's block P because we've been paying attention. So there's the normal force going upwards. Then on this block we have the string pulling it to the right. So to the right we will have tension. And I'm sure you're all drawing this with your ruler. Am I right? And then opposing the motion we have friction. And we know there's friction because they put the word rough in the question. So there we go. 4 arrows, 4 marks. Okay. Make sure that your T and your F are lining up nicely and you drew them with a ruler. Now it says calculate the mass of block P. Remember the mass was unknown. So we're going to use Newton's laws again. Newton's laws are going to say F net equals ma. Now we don't know m. Okay, this is what we're trying to find. But we do know from this part here that it's accelerating at 0,11 meters per second. What forces are acting on the block in the horizontal plane? We've got T minus the friction, okay? And we just calculated the T in the previous question, so it's 29,07 minus. The magnitude of the friction is 27 newtons, so this is minus 27. It's going to be 0,11 m. Okay, remember here when it says to you the magnitude, they're just telling you the number. So then we've got something like 2,07 equals 0,11 m. And then by algebra, your best friend, you end up with, I've got something like 18,82 kilograms. Remember, it must be in kilograms because it's a mass. Okay, and there we go. We've solved this question. Now, if you've looked at this question, there is another way to solve this question using work, energy, and power, but it's needlessly complicated, and this is easier, but you will get a slightly different answer if you used work, energy, and power.